those quizzes in. Let's go. We should be way done by now, folks. All you have to do is plug some numbers in and hopefully the right formula. All right, let's get out our practice test. We're going to get through the first practice test today. Hopefully. All right, here we go. Quizzes are turned in. And everybody's attention is getting focused. We'll be having a test at the end of next week. Not sure the exact date, but I'm going to figure it out and put it in Power School today. Tonight. If you are going on retreat, are you going to talk about this? Is everybody in here going on retreat? Q is going on retreat.
I'm going because I can't go on.
Never in your life? We have to know by now.
That's disgusting.
You don't like those?
Amazing. No, they like.
Anybody else
like
on retreat? Oh, we got one.
Also eat it.
Okay. You're going on your hand up. No.
Just eat it whole.
Solomon. Okay, retreats are doing anything. I encourage everybody to go. If you are, obviously Precal C, no one, not even you. So, we're going to be plowing through. But the good news is, it's just going to be review that you missed. So, this is a good time to be gone. You just have to be disciplined enough to watch the videos. You know, like today I'm going to video this practice test. I'll videotape all the other ones. You need to watch those. And then make up the test that you're going to miss. Now, you have 2 weeks to get that test made up. All right, 2 full weeks. So there's no pressure on you. If you have to get something else done, you'll get that stuff done. But in 2 weeks, you should have this done. And of course, we'll be continuing to move forward during that time. So no need to worry about missing school. Retreat is worth it. It is worth it. But if you need to take care of business, watch the videos and be ready for your test. All right, we are doing the practice test. Number 1. When are we going to lunch? Whenever I determine it's time to go to lunch, okay? So stay focused, be good, keep me in a good mood, and I'll let you go to lunch sometime. All right, here we go. The first part of the practice test is your exponent simplification. If you struggle with this, pay real close attention and then maybe go back, recopy them, and redo them again. Certainly, before you start writing on this, if you want to take pictures of it so that you can put it in Notability and do it again, that would be fine. With your phone, you can do that. But you need to be practicing to the point that you know what you're doing. All right, here we go. I see a negative exponent. Do you? A negative exponent means flip it over. So this is going to be 9/4 to the 3/2. Now, notice what flipped. What flipped is the thing that's going to the power. The power doesn't flip. You flip the fraction. So now we have this. What does a fractional exponent tell us? Radical. A radical. So we got the square root of 9/4. That's the square root of 9/4, but it has to be cubed. So this tells me I'm square rooting, and then that tells me I'm raising to the 3rd power. So what is the square root of 9? 3. The square root of 4? 2. And then I still have to cube that. So 3 cubed is 27, and 2 cubed is 8. Remember that when we say cubed, we mean times itself 3 times. So 3 times 3 times 3, 2 times 2 times 2. Lots of steps to that problem. Not hard, but lots of steps to keep track of. Is everyone okay with that? Now the next one is an easier version. It's the same kind of problem, but it's easier. First of all, are we going to do any flipping? No. But there is a fractional exponent That is a 2, so this is another square root. And that's a 1, so I don't have to do anything. I just have to take the square root. So the square root is 3/4. Done. Now the next one has a lot going on. And you can do this in whatever order you want. So remember, the two main ways to start are to simplify inside the parentheses if there's anything to clean up in there, or you can go ahead and take care of this first. All right, that's your choice. That's completely up to you. So Lauren, how would you start that problem? Inside?
Yeah.
So she started by simplifying in here. Remember, that's an option. You don't have to do it that way. I like to do it that way too. So I'm going to simplify inside. So I have an x to the 5th over an x to the 10th. Who has more?
The bottom.
How many more?
5.
So you have x to the 5th on the bottom. That takes care of these guys.
The y goes to the bottom.
All right, now see that negative exponent?
Can't be up there.
Can't be up there. Well, it can't have a negative. So he's coming down. So 3 are coming down. There's already 7 down there. So now we're going to have 10. These 3 are coming down to join the 7. Now we still have to square it. So 4 squared, 9 squared. Now be careful here. When you raise x to the 5th to another power, what do we do with those powers? Multiply them, that's right. So x to the 10th, y to the 20th. And that is our answer. All right. Solomon, you paying attention, sweetheart? Okay. All right, 64x to the negative 7. This is such a simple problem, but it can be a little bit tricky if you're not paying attention, because everybody sees the negative exponent, right? Everybody knows what that means. But what's going down to the bottom?
The x.
Just the x. When we had this on a quiz, some of you did 1 over, and this is not 1 over. This is 64 over x to the 7. All right, what's our general rule? If it's on the practice test, it's on the test. So don't make a mistake with that problem. That should be easy for you. All right, 1/9 to the negative 2nd. All right, what does the negative right here tell you? To flip the fraction. So it becomes 9 over 1, or just 9 squared. 81. Done. Okay? All right, complete each sequence and identify it as geometric or not geometric. So you're going to fill in the blanks in the sequence and then decide if it's geometric or not. So this is kind of two-pronged. First of all, you got to just recognize what's going on. And sometimes that's harder for some of us than others. So you really just got to look at, we got a 9, a 16, and a 25. Now, wait a minute. Those numbers are special, aren't they? What about those numbers?
3, 6, 9.
Okay.
Oh, 3, 4, 5 squared.
They're the squares, aren't they? This is 3 squared, This is 4 squared and this is 5 squared. So what do you think this number is going to be? 36 and 49. And then let's go backwards. This one would be 4 and 1. Is it geometric? No, because what does geometric mean? You get from term to term by multiplying by the same number. So if this were geometric, here I times by 4, so this number would have to be 16, not 9. Having a pattern, all sequences have a pattern. To be geometric, that pattern has to be times the same number. All right, what about the next one? Same thing. You're thinking what? I heard somebody say something. Times 3. Certainly 27 times 3 is 81.
Yes.
And 3 times, ooh, that was a 1, wasn't it?
Yes, ma'am.
And 3 times a third is 1. So let's see if it works. We took times 3, so now we'll take this times 3, and this times 3, and times 3 times 3. This one would be 243.
729.
729. Thank goodness we have a calculator. We'll have our calculator to help us. Is this geometric? Yes. This one is geometric because we're timesing by 3. Alright, so here we have an equation. Now you will have your note card obviously with you to help you with some of the problems. But right now, you don't need your note card because they give you the equation. This is the equation we're using for this problem. So we want to know the horizontal asymptote, the y-intercept, and if it's increasing or decreasing. Okay, so you got to remember some stuff now to do this one. Mikey, what do you remember?
It would be decreasing since the thing in the parentheses is also.
Very good. This is a decreasing exponential. Remember, your exponentials either look like this, so shooting up into space, or they look like this, coming down. This is a picture, hopefully, of your salaries. Hopefully you're going to get a raise every year, so your salary's going to go up. This is a picture of your car value. Most of our cars, their value decreases over time. Okay? So remember that if something's increasing, it's 1 plus whatever. So like 1 plus 6%. And if it's decreasing, it's 1 minus 6%. So Mikey said, see that number right there? That's less than 1. That means we did 1 minus something. And if we did 1 minus something, we are decreasing. Does everybody follow that discussion? So this number right here tells you if you are increasing or decreasing. Greater than 1, we're growing. Less than 1, we're shrinking. Very good, Mikey. All right, somebody else remember something. Izzy?
The y-intercept, you're going to do comma 0. And then
Exactly.
1.
Very good, Izzy. You made my day. To find a y-intercept, we're going to let x be 0. In any equation, anywhere, in any math class, to find the y-intercept, you're going to let x be 0. So, you can type this in on your calculator if you need to, but most of us know that 0.2 to the 0 is 1, and 1 times 3 is 3, plus 1 is 4. But if you want to type that in, I can't stop you. You have a calculator. Type it in. Let x be 0. Okay? Anybody remember anything about the horizontal asymptote, Sam?
The horizontal asymptote equals 1.
And well, it's y equals 1.
Oh, yeah, y.
And why is that, Sam? You don't know? Well, you're right. I don't know why you think it's 1, but you are right. Anybody remember why it's 1? Remember, your standard exponentials have an asymptote at 0. That's where the asymptotes for exponentials are, at 0. When you take an equation and stick a +1 on it, what does it do? It picks that up 1. So what was 0 is now up at 1. So this number is going to always give you the horizontal asymptote, right? In an exponential, not necessarily in another function, but in an exponential. Okay? Everybody got that? Yeah. Now, it's easy when I'm standing up here saying it, you have to remember those rules. Okay. All right, next. Consider this sequence. Find the common ratio. So it must be geometric if we're finding a common ratio. So, Macy, you need something, honey?
What?
You need something?
Oh, I was just asking for water.
Well, honey, no one wants to share water with you.
Okay, but if you waterfall, it's fine. Waterfall is like.
All right.
How?
Find the common ratio. What's the common ratio? 4 times 4. So the common ratio is 4. We are getting from term to term by multiplying by 4. Very good. Now, find the 7th term. The 7th term. Okay. You know how to do that? Well, you should somewhere on your paper have this formula written, so in case you forget, you can always look at the formula. But most of you remember, you take the first term times the ratio to the 1 less power, right?
Yeah.
So we type that in on our trusty calculator. And I got 12288. What's problem C asking me to find? The sum of 6 terms. Pay attention to that subscript, kids. This one was a 7, just randomly because that's what I wrote down. This one's a 6. Pay attention to that. Make sure you're using the right numbers. So our formula, it's on your note card, says 3 minus 3 times 4 to the 6th over 1 minus 4.
Move up the academic then.
What's the matter?
Mad because I'm participating.
Now, what goes in the denominator? Let's do our denominator first. It's just -3. So now I can type in my numerator and then just divide by -3. So 3 minus 3 times 4 to the 6th equals, divided by -3. I got 4095 as my answer. Good job. All right, we're going to do this number 5, and then we will go to lunch. So here we go. Number 5. Well, we don't have to go to lunch if you don't want to.
Divide.
So step one, we're going to divide by 4. Everybody okay with that? That makes sense. It's how we solve equations. So when we divide by 4, we get 1.8. Now be careful. We talked about this yesterday. I think it was yesterday. It was someday, not very long ago. When the x is after the function like this, when it says log x or sine x, in order to find x, we need to not log, but second log. So if you second log, so second log 1.8, you should get 63.10. It's 0.95.
The 10,000.
Oh, does it say? Oh, 10,000. Thank you, Izzy. So that would be 63.0957.
Yes.
10,000, thank you, is 4 decimal places? Yes.
Do you think we'd have to run a for test?
I don't know. We'll just have to read the directions.
Yes, so.
All right, everybody got that one?
Yeah.
All right, let's look at the next one. 3 log 8 plus 1 equals x. So 3 log 8 plus 1 equals x. Now, are we going to be regular logging or second logging in this problem? Regular logging, because we only second when the x is after the function like this, right? So, we're not ready to type in though yet. What do we have to do first? Oh, actually, we can type in, can't we? Yeah, we can just type that in. So 3 log 8, what do we have to remember to do? Close the parentheses, plus what? 3 log 8 plus 1, 3.7093. Type 3 log 8 plus 1. Make sure you close the parentheses after the 8.
That's because you guys added.
No, that's because.
No, that's correct.
No, that's because you guys added the 1.
Yeah, they did the one before.
Mrs. Ford is right.
Yeah.
Guys, you're solving for x, and x is already by itself.
Alright.
So you're just going to type in 3 log 8 plus 1, and that's going to give you your x value.
The 8 goes with the log and not the plus 1.
Yes, you got to close your parentheses. Every time you do a log, you have to close the parentheses. 3 log 8, close those parentheses, plus 1. Yep. And then log x equals negative 0.23. Look where the x is. What am I going to have to press? Second log negative 2.3. And x equals 0.0050.
Yes.
Yep, you can go to lunch and be back at 49. Back at 49.
Sure, we done.
Yard time.
Back at 12:20.
It's 15. Okay, it's 15.